All right, we're back here in section 2.1, the second part, and we're going to be talking about transforming data. And so let's first of all talk about adding, which adding, subtracting, the same thing, right? Because you could add negative numbers. So when you take a distribution and if you add a number, let's say A, or subtract it, the measures of center and location, okay, so your mean, five number, summary, percentiles, okay, that's going to add 8 all those, okay, but it's not going to change the measures of variability like range, interquartile range, or standard deviation. So basically what it does is the effect of adding something, it's going to shift it to the right or left, but everything's going to stay kind of the same, so it's not going to spread out anymore. Okay, so it doesn't change the shape of that distribution. All right, so there we go. Let's get going on the next part here. So we got this. So let's take a look. Soon after the metric system was introduced in Australia, a group of students was asked to guess the width of their classroom to the nearest meter. Now, the actual width of the room was 13 meters, and now we can examine the distribution of students' errors by defining this as being their error, just say is their guess minus 13. So that's how far off they were. So that's going to be their error. And we have those plotted here on a nice little dot plot here, okay? So the next question might be is, well, what shape does the distribution of error have if we were to do the error, if we were to take each of those values and subtract 13? Well, basically everything here, we're just going to shift everything down 13. So basically, as we kind of talk about here, it's still going to stay skewed to the right and has two distinct peaks, obviously. All right, and then the next question might be, well, find the mean and median of the distribution. Well, if the mean right down here was 16.02, well, we just subtract 13 from that, it's going to be 3.02. And then the median, of course, was 15. It's now going to go down to 2 is what we're going to see there. So whatever you do to the numbers, that's what you do to the mean and the median. All right. What about the standard deviation and the interquartile range? Now remember, standard deviation that we have here, again, they use the SX here, that's going to be 7.14. Again, that's going to stay the same, and so is the interquartile range. Interquartile range is still going to stay at 6 as we have it there. So again, those things are not affected if we add or subtract. Okay, so we can kind of see this as we subtract 13 from all. Yeah, it's the same. It looks like it's the same exact graph, except it's been moved down 13. Okay, so those measures of center change, but you can see it's not any more spread out than what it was before, and that's why those measures of variability remain constant. They don't change. All right, what about multiplying? Now, multiplying, again, could be dividing. We know multiplying by the reciprocal is actually dividing, so it's the same thing. Now, when you multiply the measure of center and location by a number, let's say b, you're going to do this. You're going to multiply those values by b. And the variability, it is going to spread it out more because you're multiplying those values. So yeah, you are going to multiply all those measures of variability by b as well. So the range, interquartile range, standard deviation, whatever you multiply by, multiply those as well. It's not going to change the shape of the distribution. It's just going to spread it out is what it's going to do. Or pinch it together if it's dividing. Okay, so again, let's talk about this. The same data that we had before is that because the students are having some difficulty, they just got introduced to the metric system. It may not be helpful to tell them their guesses tended to be about 2 meters too large. So what we're going to do is we're going to convert that error data back to feet, so that gets it back a little more familiar to them. And to convert meters to feet, there's 3.28 feet per meter. So we're going to take all those errors and multiply them by 3.28. So what's going to happen is the shape skewed right. It's going to stay skewed right, okay, with two distinct peaks. The median of the distribution, well, if the median here was 2, well, we're going to multiply that by 3.28 and get 6.56 feet. Okay, now the interquartile range, now before is 4 minus a negative 2, so that interquartile range was 6. So now we're going to multiply that by 3.28, and now the interquartile range is more spread out at 19.68 feet. So again, you can kind of see what happens with the data, the original, and when we multiply by 3.28, yeah, it still keeps that same shape, it's just the numbers spread out a little bit more. So that's why that variability increases, whereas by adding, it just shifts it without spreading it out anymore. All right, so again, learning targets that we have here from the first part, we should be able to find the percentile of an individual within a distribution. We should be able to estimate percentiles using the cumulative relative frequency graph. That z-score, the standardized score, that z-score should be able to figure out that. Again, that's where you take the actual score minus the mean divided by the standard deviation. And then, of course, we should be able to talk about transforming data. What if we add, subtract, multiply, or divide? What happens to our shapes, their centers, and variabilities of those distributions? So that's section 1 out of chapter 2. Until next time, I am Mr. Bowen.